Will the physical dimensions of the pan make a difference to the height of the fireball?
So our scale experiment is pretty much ready to go. I've got several other types of frying pans and Jamie's beret liner just to find out which shape we think is most energetic.
Just like their large-scale outdoor tests, they've got a gauge behind the stove that will measure the fireball heights. Now, although the oil-to-water ratio is the same as their earlier tests, 8-to-1...
Okay, that's 8 teaspoons full of oil.
Adam's worried the miniature amounts may be too small.
All right, well, now we need 1 teaspoon up there.
So, first up, it's a quick fireball test to see if the mini-me measure will still do the job.
Here we go. Scale kitchen conflagration. 1 teaspoon of water. Wow!
Yep, it's frightening stuff. Even a tiny amount of water can still cause a kitchen catastrophe.
I think we're going to need a smaller scale. Well, we are continuing to discover that there is, I think the scientific term is crap load, a crap load of energy inherent in cooking oil when you heat it up and then add water to it.
But that energy does mean their tiny teaspoon scale is a good enough yardstick to test the pot shapes. First up, the wok. Will its oval shape help focus the flame?
This is 1 teaspoon of water and 8 teaspoons of peanut oil in a wok. 3, 2, 1.
Next, a standard pot.
3, 2, 1. Oh.
Nice.
And finally, a stovepipe-shaped pot.
Jamie lights the fire.
Maybe it will act like a cannon and direct the blast upwards.
Here we go.
Okay, go. Pretty much the same.
Yeah, that wasn't bigger than the pot, was it?
No.
Darn it!
With all their pot tests delivering similar results, it's bad news for the myth.
So far, it looks like pot shape doesn't really matter. So the idea of 8 ounces of water creating a 30-foot fireball is, well, busted. The only thing left to try from here is adding more water, and we'll see what we get.
So with the pot size out of contention,
There we go.
the boys are going to see if throwing more water on the flaming oil will provoke a more furious flame.
Last time we did 8-to-1. This time we're going to do 4-to-1, and we'll ramp it up from there.
So will twice the ratio of water shoot the flames twice as high?
I think we're going to get a bigger poof of a fireball. There we go. Here we go. 3, 2, 1. Hard to say if that was bigger. It was at least as big.
But as big is not big enough. They want bigger and better fireballs. So the boys up the water volume again. 2-to-1. Half as much water as oil.
3, 2, 1.
It's getting better, but there's room for one final test. Equal parts oil and water.
Here we go. In 3, 2, 1.
Clearly, there's not much in it, but the guys feel that there is some improvement at the higher ratios.
I don't know, man. It's really close, but if I had to call the ideal ratio of water to oil, I'd say it's either the 2-to-1 or the 1-to-1 ratio.
Yeah, I'd make the same call. But, you know, it is kind of like making the decision as to whether you want to be well done or really well done.
Yeah.
I wouldn't want to be in either of them.
No.
But will that marginal difference make a difference in full scale? Will they finally fire up the mythical 30-foot fireball?